Welcome y'all back to Smart Geometry. Today we're talking about line segments. So, quick review. Yesterday we talked about points, single dots, points. We talked about lines. Remember, lines take at least two dots to make one line. And to denounce lines, you gotta make sure you put arrows. Because remember, lines go forever in opposite directions. And of course, you talked about planes. Now, planes are surfaces. So to make a plane, you need at least three non-collinear points. So 3 points not in the same line. So that if you have 3 points in the same line, then technically you can have an infinite number of planes travel through that right there. So 3 non-collinear points. Now, I specifically say lines go for infinitely in opposite directions because you can't measure lines because there's no start and there's no end. It just goes forever. But line segments are part of lines, little part that has an endpoint on both sides. So, for example, this has endpoint A and endpoint B. Now, they're both called endpoint. There's no start point and endpoint because they're both. There's no there's no certain place to start or finish. So that's why I asked the question, what are the 2 possible names for this segment up here? You can call it segment AB. Remember, you just put a single bar without the arrows, or you can call it segment BA, arrow. Again, just straight across, no arrows at the end. Now, how can we divide segments into smaller segments? Just add points. The more points you add, the more segments you create, whether they're really small, close to each other, or far away from each other. You create segments. So that kind of leads to this betweenness of points. Betweenness of points is just a fancy way of saying, hey, sometimes you can just stick a random point in between these two, and you just break it up into smaller sections. Doesn't mean that's the whole value of AB. It just creates 2 smaller segments. So when it comes to in-betweeners of points, they usually do that because they want you to say, like, hey, I got 12.8 and 9.7. The question is, what is AB? What's the length of the whole thing? Well, first off, let's talk about AB. AB, segment AB, is made up of 2 parts. It's made up of segment AN and, of course, segment NB. So AN and NB together gives us AB. That being said, when it comes time to actually find the value of this right here, we say, hey, well, AB, like we said, is made up of AN plus NB. Well, AN also equals 12.8, and NB equals 9.7. So if I add them together, that gives me 22.5. So that's the length of segment AB right there. So let's kind of move on and talk about congruentness. So the question I asked in class, like, hey, what in here, which in the definition of congruent, tells you what does congruent mean? Well, the only thing that's different from congruent segment and segments that have the same measure is the word same. Same meaning exactly the same. So there is a sign for congruent. That's an equal sign with a squiggle on top. That means that 2 things are congruent. So, for example, another way to say things are congruent is these single marks right here. It's saying that this segment, GH, and they put it in the middle to let you know they're related to each other. This one right here is congruent to this one over here, to CD. Or, if they have 2, those 2 match up to each other. So, just because it has 2 doesn't mean they're super congruent. No. It's just saying that the one that has 2 matches up to the one that has 2. So, to verify, does 1/2 equal the same as 0.5? Yes. Does 1 and 2 over 3 have the same value as 5 over 3? Yeah. So you can say that segment G, that's a weird G, GH, segment GH, is congruent to CD. Now, when you say it in that sense, we may not actually, whether we know what the measurements are or not, by saying they're congruent, we can say they're the same. But when you say the values are equal, you'll just say segment GH is equal to CD. That's now measuring proportion. That's measuring actual value, the 1/2. So the first practice problem that we had today was this one right here. We had PQR. We talking about segment PQ. You had 2 questions. The first question was find X. So find the value of X as it is down here. And then find the value of PR. How long is PR? Segment PR. Alright, let's start with the first one. So we look at our picture right here, like, alright, we got these little lines right here. So that means that this segment right here from P to Q, from here to here, is congruent to the other segment that has the same little hash mark there from Q to R. So we can say PQ is congruent to QR. Well, it also says that PQ equals 6x plus 20. That's good to know. So we can say 6x plus 20. And we know that QR also equals 2 parentheses x plus 6. So we can then say 6x plus 20 equals the 2 parentheses x plus 6. This is how we're going to find the value of x, because we know that these two segments equal to each other, so the individual little equations also equal each other. So we'll distribute the value of 2 through, and we end up getting 2x plus 12 on one side. On the other side, we bring it all down, 6x plus 20. Now I need to get x by itself. Any algebra problem, you gotta get x by itself. So to do so, I'm going to subtract the value of 2x to bring it over here to the other one, minus 2x. So we end up getting 4x plus 20 equals 12. Now I gotta get, again, we gotta get the value of x by itself. We got all the x's together. Good. Now I gotta get rid of all the numbers. So we start with this 20. Minus 20, minus 20. We end up getting 4x equals a negative 8. So we get a negative 8. And that's okay. And then we're going to divide by 4, because that's 4 times x. So we divide both sides by 4. We end up getting x equals negative 2. So our value of x is negative 2. Now, we need to go find the next question is what is from P all the way over here to R. So, now that's, like we said earlier, PR, the segment PR is equal to the two individual parts, which is PQ plus QR. So that means PR is equal to the individual equations as well, summed up, added up. So we're going to substitute this PQ with 6x plus 20, and we're going to substitute the value of QR with 2 parentheses x plus 6. There's going to be a lot of substitution throughout this homework, so make sure you are doing that so you can get everything straight. Now earlier we found that x equals negative 2, so we're going to plug those in here instead of the x. Now I'm doing a lot of math just to show you where everything came from, so you don't know that it was made up. But there's a lot of steps you can kind of skip when you're able to do this math in your head. So here we're going to do 6 parentheses negative 2 plus 20 plus 2 parentheses negative 2 plus 6. Now this negative 2 plus 6, that will give us a 4, so I'm going to just go ahead and put a 4 there. And then we'll take care of it. So 6 times a negative 2, that gives us a negative 12, plus our 20. And then here we end up getting 2 times 4. Get that, we get 8. We add these two, negative 12 plus 20, that gives us a positive 8. We add these two together, we end up getting 16 as a final answer here. So hopefully you guys got 16. I got 16. I think lots of you guys got that 16 in class. There was one way somebody did differently. They say, hey, I just found one of these and doubled it because I know they're congruent. And that's a great way to do this. You just got to take one. Take the negative 6, put the negative 2 plus 20. I get negative 12 plus 20. Add them up. You get positive 8, sorry. And then just add another 8 because the other side is also congruent to it. That also gives us 16. That's perfectly fine as well. You can do it that way. The last example that we had here was a little word problem. It says find the value of x and BC if B is between C and D. So they don't give you a picture this time to refer to. So you're going to have to create one for yourself. So here we're going to just draw a line. That's a bad line, man. The later I do this, the harder these lines get. All right, so I got endpoint C, endpoint D, and B is just somewhere between. So because I've done this problem a couple of times, but you could read this and say, hey, CB is 2x, BD 4x. If I had to guess which is bigger, I'm going to guess this is bigger, BD. So I'm going to make this side a little bit smaller. I'm going to put my B over here. Just so this seems a little bit more, proportional. to the problem. So they tell us that CB, so from C to B, is 2x. That's the length, quote unquote. That's the value of it, 2x. They tell us that the value from B to D, the length of that, is 4x. But they also tell us that that same BD is also 12. It's also 12. Okay, so this is the important part. We're going to first find x. To find x, we look at this. The distance from here to here is 4x. The distance from that same distance is also 12. So if these represent the exact same thing, then they have to equal each other. So 4x equals 12. That's how we're going to solve for x. So then we'll divide by 4, both sides by 4. We end up getting x equals 3. So we got the first part. We know x equals 3. That's one answer. Then they ask us, hey, what is BC? So BC and CB are the exact same thing. So the value of CB is 2x. Well, if we know 3 equals x, well, then we can say, hey, BC equals 2x. Well, then x equals 3, so that means it's 2 times the 3. So the value of BC is 6. So hopefully you got that. Hopefully this helps all y'all, and just be ready for the next one. Bye.